Hello friends, welcome back to the second lecture on semantic memory. Now in the last lecture we discussed what is semantic memory and how it is arranged, what are the properties of semantic memory and how long term memory is divided into both the semantic type and the episodic type. We also looked at what is stored in semantic memory, the kind of information, facts, knowledges, arithmetic rules, certain kind of information related to everyday world activities, everyday world knowledges, all are stored in semantic memory. And so, there is it's a kind of memory which stores most kind of information that people use in everyday life. We then discussed a distinction between the episodic semantic memory, and we looked at what is the main differences. And so, some of the main differences I will repeat here is that episodic memory is basically time dependent or temporarily arranged, whereas semantic memory is arranged according to meaning. It basically means that as a episodic memory unfolds, it unfolds in time. You can see yourself in time, whereas if an semantic memory unfolds, it unfolds as a meaning. What do I mean by this? The meaning of this is that when you unfold in an episodic memory, like let us say your prom night or maybe your graduation night. So, every event is arranged in terms of time from morning to afternoon to evening, what happened during the whole day. Whereas, if you ask questions like if you think about acts like arithmetic rule of how addition, subtraction progresses, you really do not need to know the time of the day when you learned or how they progressed in terms of time. The other differentiation between episodic and semantic memory is, in episodic memory it is when, so remembering when the incident happened, but in terms of semantic memory it is more about what happened. So, what is the content of it, and so this is one distinction between episodic and semantic memory. And so, is the focus of the memory. So, episodic memory, the focus is the self. So, everything arranged in episodic memory is around self. You as a person can see everything going around and you can watch this thing as a third person observer. But in semantic memory that is not possible. What really happens is that you gather information and you are not the self. The self is not the center stage of this memory, but rather world knowledge is the center stage. So, knowledge is basically what comes out of semantic memory. So, this is something that we saw in the last class. Now, we also saw two models of memory, semantic memory, that in the last class. One model was called the hierarchical semantic network model, where we looked at how semantic memory arranges concepts and a world information, and we saw that it arranges the world information in terms of nodes. So, there are several nodes, and so nodes are basically concepts, and these nodes, two nodes which are similar together, or even if they are dissimilar, they are connected by a pointer or a link between them. And so, this pointer node kind of a thing which is very similar to programming in C is what happens in the hierarchical semantic model. We also looked at some of the basic interesting facts about the hierarchical semantic model. And we also looked at a criticism of how it does not follow the cognitive economy on how the concept of hierarchical structure is basically violated. So, that kind of thing is what we saw in the last class. We also saw the feature integration model or the feature model of semantic memory. We saw that there are two kinds of features. So, most information is arranged in terms of features, and so there are two basic kinds of features that is available with any word, concept or knowledge. And so, one of these is called the defining feature, the other is called the characteristic feature. We also saw a model of how these features are tested. So, that is another interesting thing that has to be there. So, what really happens is that in the beginning, to start with, the feature model takes off in this way. At first we start comparing the characteristic features, and if the characteristic feature of two objects or a characteristic feature of a new event is similar to a proposed concept, the more similarity it is, the quicker a person decides the newer instance to be a part of the concept. If the feature is very low, we can go ahead and say that this particular new concept which is in front of us, this particular new item which is in front of us is not a member of the concept, and so we can delete this thing. Now, if the characteristic feature is neither very high nor very low, so we proceed to combining or testing the defining features. And so, when we look at the defining features, this is the next step. The in this case only the defining. So, if characteristic features are neither high nor very low, the defining features are tested, and when the defining features we get a match of the number of defining features, a yes answer comes in, then the new item or the new enterant is basically matched to the concept and a yes signal is given. Or if the defining features, number of defining features are very low in the new item as compared to the concept, it a no signal is outputted, and basically it is rejected that the item belongs to this concept. And so, this is how the idea of feature integration model really works. We also looked at some of the interesting things about the feature integration model. For example, how it progresses and what are the how it solves the hierarchy problem, or it goes ahead and solves category problem. So, what it basically says is, as category increases, more and more abstraction comes in, and so with the increase in category, the or increase in the size of the category, this process of similarity matching becomes more and more difficult. Now, in today's class, we will look at some of the newer models which are there, some of the more models which are there, and then further on we will look into something called how beside the model, the concept of model, how is semantic memory supposed to store information. So, we will start with model proposed by Collins and Loftus in 1975. And so, Collins and Loftus, they basically went ahead and they proposed a model which is very similar to the hierarchical semantic model. And so, what the basic of this model is, it is an elaboration of Collins and Quillen's 1969 model. As I said, it is an extension of the original model proposed by Collins and Quillen. And so, basically this model also states that semantic information or world knowledge is basically integrated together, or world knowledge is stored into the semantic network in terms of nodes, where nodes is the concept and pointers, the pointers are the links between these concepts. So, hierarchical model, the only change that this model brings about is that in this model the concept of spreading activation is the center point or is the central feature of this model. So, then what does this model basically say? The model conceives of semantic memory as a network with nodes in the network corresponding to concepts. So, what this model says is that the semantic memory or semantic information, world information is arranged in terms of a node or in a network of nodes. And so, in this network, the nodes which we are talking about, the central point from which communication occurs, these are called the nodes. The nodes are the concepts, and basically the nodes which stores the basic features of the concepts, or the nodes are always the superordinate nodes. So, concept storing nodes are always the superordinate nodes. Also, they saw related concepts is related by connected in paths of the network. So, if two concepts are related together, they are connected by some kind of a pointer or some kind of a link, and this link is basically called the pointer. Now, the more similar two nodes are, the more similar two concepts are, the higher the weight between these links. So, basically if two concepts are similar, the path running between these concepts or the pointer running between these concepts will have a higher weight than if two concepts are connected which have very dissimilar properties or very dissimilar features. Now, how do we think about this? So, for example, let us think about fire and sunset. Now, both fire and sunset, they are not connected together, they should not be connected together, because fire relates to some other concept, some other network, and sunset is related to another network, but then there is one feature of fire and sunset which are similar, and that is the color red. So, one relation between fire and the sunset is red, but this, since they are not related together, the pointer running between fire and sunset should have a lesser weight. But then if I am talking about bread and butter, although, or king and queen, when I am talking about king and queen, these two nodes or these two items in a particular network are originating from two different networks, but since king and queen are connected by also through a intermediary network or intermediary pointer, and so each time when I say king, a queen really comes in, or the in a paired associate testing, the queen is the answer to king most of the time. So, if you ask people king and then ask them to say the first word that comes to the mind, that is queen is what the comes in, then what really happens is these two concepts are connected by a pointer which has very high weight. Similarly, pointers connecting bread and butter or pointers connecting between shoe and shoelaces are very high weights than pointers which are dissimilar, pointers connecting a desk and an aeroplane. So, although they would be related or they will be feebly related, but the pointer which connects these two nodes or these two items will be very weakly related, and so that is what this model says. They first further asserted that, so in this particular model it was further said that when one mode is activated, the excitation of the node spreads down a path or links of related nodes. So, what happens is similar to the concept of spreading activation, and so what, taking back from the idea of spreading activation, what this concept says is that as soon as a node is activated, if soon as there is some energy is provided to a node, this energy spreads down through not only through this node, but all connected nodes, all connected links. So, if I am activating the animal node, what would happen is the energy will spread down to all kind of animals which are there. It could be birds, it could be mammals, it could be reptiles, it could be all kind of animals, and so from there it will further process down, or it will spread down to other within mammals, it will spread down to all kind of mammals which are there. So, it may be lion, tiger and so on and so forth. In terms of reptiles, it will spread down to snakes, to alligators and to so on and so forth. In terms of birds, it will spread down to different kind of birds, whether it is a feathered bird, non-feathered bird and so on and so on. So, basically this is how the idea is. What this model says is that when an energy is provided to a particular node, this energy spreads down through all connected and all linked nodes. Now, this particular theories or these theorists, they believe that as activation spreads down the path or links to a related node, so the activation spreads outwardly and decreases in strength. Basically what it means is that as the node, as the energy, it moves down a node, what happens is this energy, since it channelized, it gets channelized into so many other nodes, the energy becomes decreased in strength. So, if two nodes are far apart, if two connecting items or two connecting nodes are far apart from each other in terms of a number of pointers or fourth or fifth or sixth level relation, and on the sixth level relation, the energy which starts from the top of the node will be very decreased. So, when activation spreads outward, it decreases in strength, and as I said that both aeroplane and desk are related, but they are weakly related because the energy which is activated when I say or when I activate the concept of an aeroplane or any flying object should be the highest concept under which aeroplane would fall. So, when that is activated, although desk will be activated in some way, but the energy spread will be very low, because somehow somewhere they will be related, but since they are so further out related, the weights are very low and the energy that reaches to desk from an aeroplane will be very low. And so, what they also say is that activating related concepts when an activation starts, when the spreading activation, when any activation or when any node is energized, it activates very related concepts with high amount of energies, and distant concepts are or distant nodes are activated with less energy, and that is what is supposed to be, right. So, nodes which are related together or semantically or perceptually or any kind of relations are there between nodes, they would be very closer together. And so, when a particular node, when the top node is energized, then similar nodes, since they are very close to each other, they will receive maximum energy. But those nodes which are further apart or which are very dissimilar to the particular node in question, then the energy which is coming to these nodes will be very less or it will be very low. So, think of this in this way. So, let us say that we have a node of animal, and so within animal, or let us say I have a node of living things. So, I have a top order node of living things, and so within living things I will have two nodes which are animals and plants. And within animals, let us say I will just put two categories. I will have mammals and birds, and within plants I will have trees and shrubs. And so, within mammals I will further have, let us say lion, tiger is one category, and the other mammal is monkey, orangutan. Within birds I will have the feathered birds. So, I will have something like a parrot, and I will have a non-feathered bird. So, I will have something like an ostrich. And within this also, so within trees I will have an apple tree, or I will have a pine tree, and shrubs similarly, let us suppose I have A and B as. Now, what does this model explain, and how does this model go ahead and explain? So, let us say if living thing is the node, and these are the pointers to the node. So, remember these are the nodes, and this is the pointer which shows the spread of energy. So, what it says is, when any node is activated, energy spreads down equally to these nodes, right. And so, when a node, let us say if a node lion is activated, now somewhere across this lion will be related to this apple tree or this tree, right. Some kind of connections would be there. So, lion lives in forest and forest has trees, and so they will be connected somehow or the other. But what this model particularly says is that when this is energized, and if lion is the node which is energized, and this is how the energy is moving, then concepts which are closely related together, for example, lion, mammal, animal and living things, they will have a stronger connection, stronger weight, and so more energy will be spread here, or more of them energy is invested into this node than for the plants, although plants are living things, but since the lion node is energized, and so energy will be spread to these nodes. So, birds will receive lesser energy, similarly the monkey will receive less energy, similarly feathered and non-feathered birds will receive less energy. Also, no question of energy distribution here, or very less energy distribution here, but the most energy distribution will be to the node lion, mammal, animal and living things. And this is what this model says. So, if first of all energy spreads, it moves down, and as it moves down it spreads out. So, energy will be basically moving to all directions, right. And so, here the lesser energy is invested in these parts than in this part, and this is what the basic proposition of this model is. And so, as I was talking about, so this is how the model looks like. So, this is the animal node, this is the bird node, this is the chicken node, and so within the bird node you have the chicken node. And so, you look into it. So, let us say if feet or if robin is activated, then this particular node will be energized, and so high energy will be, or more energy is spent into this node than the nodes with chicken or the nodes with eye, feathers, and so these are also nodes. These are also certain nodes which are there, which are connected pointers. So, these nodes will not receive enough sufficient energy, but these nodes will receive sufficient energy, and so will these nodes, because they are connected to robin. Also, these nodes which are there, legs, breath, eyes, ears and so on and so forth, will not be receiving energy. And so, that is what the model talks about, and this is a way of it. So, basically this model is just an extension of the hierarchical symmetric model. The only difference is that it talks about this spreading activation of how energy spreads when it starts when it is activated at the top, and how it filters down, or how it moves down from there. So, in this model the idea is that very similar concepts have many connecting links and are placed close to each other. So, what this model says is that similar concepts which share certain features, certain distinctive features with each other, they are placed together or they are blocked in some kind of a block which have very close proximity with each other, right. Now, or each link and connection between two concepts is thought to have a certain weight or set of weights, and as I was explaining, now since two concepts are related to each other or they are placed in close proximity to each other, these links will have very higher weight. So, as two links, the more similar two links are, the more similar two nodes are, the stronger the weight between them and the more energy or more energized they will become than two nodes which are dissimilar with each other. Now, the criticism to this model, the criticism is that the model is the breadth of the model. The breadth of the model is so huge that it is difficult to make clear and strong predictions from the model regarding empirical findings. So, the model is so huge, it talks about that everything is connected to everything, and there is this weight, the idea of weight and the idea of how it is connected to each other. And another problem with this model is what makes two concepts similar. So, this similarity concept or this idea of similarity has not been explained by this model, and so it is a difficulty, it is a genuine difficulty with this model of how do we encompass or how do we study this similarity that we are talking about, what do we call similarity. So, are we talking about the defining features, are we talking about the characteristic features, what makes similarity similar, and so this is one thing or one problem with this model. And so, in opposition to this model, not exactly direct opposition to this model, another interesting model was proposed for semantic memory, and this is called the Anderson's ACT or ACPR model. So, what is this model? It was proposed by John Anderson in 1976, and it is called the adaptive control of thought model of memory. It is also known as ACT, ACT star, ACTR, and so on and so forth. So, those of you who do modeling or who do computational modeling will be very familiar with the ACTR structure, the adaptive control of thought. Now, that basically what is it? It's a process model, it's a process orientation model, and so this process orientation model basically it's kind of a box pointer model. Remember the first class that we did, we talked about two kinds of model, the box and pointer model, and we also talked about the connectivist model where we have a unit, input link and output link and a hidden link. So, the next model that we talk about, the connectivist model, is basically of that type. Now, this is a box and pointer model. And so, what does this model say? So, based on analogies to computers, ACT gives rise to several computer simulations of cognitive processing in different tasks. So, basically this model has certain conceptualizations of how information is stored in our memory, basically world information or common sense information with implicit knowledge is stored in our memory. So, what are these conceptualizations that this model says? Now, the first conceptualization that this model talks about is that it distinguishes between the three types of memory systems. It says that the human memory system is basically arranged in three different types or three different ways of looking into it. It is arranged in terms of declarative memories. Now, declarative memories is that memory which will have more all information, facts, knowledge, arithmetic rule, world knowledge, everything into it. And so, there is no distinction of the episodic and the semantic here. And so, this model looks at declarative memory is the storehouse of all kinds of information, whether it is personal information, whether it is self related information or event related information or fact related information. And so, the first conceptualization of this model is that there is something called declarative memory, and this declarative memory has all kinds of information that should be present or that is present in this world. Also, there is a conceptualization of working memory, which is information that is currently at the highest level of activation. So, it talks about working memory, or working memory is that kind of memory according to ACTR or adaptive control of thought model, which we are using right now. So, although declarative memory stores a lot of information, it has a lot of information, and so I will explain to you the how this declarative memory really works. So, basically declarative memory is conceived as a model with nodes, it is similar to the hierarchical semantic model, and so there are nodes, and these nodes are connected by weights, and these weights are determined by the strength of the pointer or the similarity between two nodes. So, basically that is how declarative memory is stored, but declarative memory cannot on its own do anything, and so there is a conceptualization of working memory. Working memory is that part of memory or that kind of memory which is active at any point of time. So, when I am accessing declarative memory, the kind of memory which is accessing and doing all operations onto declarative memory is called the working memory. It is memory at the highest level. So, information access and information processing are all those operations which are doing the information processing and accessing memory from declarative store is basically what is called the working memory. So, think of working memory as a part of declarative memory, but it is that part which is active, which is doing the processing or which is running the operations or the rules of the game which it is running is what is the working memory. And next to it is the idea of procedural memory. So, procedural memory is a kind of memory which is procedure based, but and it works onto or it works something like in terms of production rules. So, there are certain production rules, we will come to explain that also. So, there are certain production rules, there are certain ways of doing things, and the procedural memory is basically a kind of memory which follow these rules and does a particular kind of an act, right. So, basically then this memory talks about declarative memory in this way. So, Anderson 83 believed that declarative memory stores information in network that contain nodes. As I said before, what declarative memory generally tends to do, it has a large vast network, and these networks has concepts which are stored as nodes, and so all concepts which have similar features or similarity based kind of matching is there. So, those concepts which are similar are clubbed together, and these have the highest weight, and the weight is basically the strength of how close two concepts are, and so these have higher weights and they are connected by some kind of a pointer. So, this is how declarative memory is all about. Now, there are different type of nodes, including those corresponding to spatial images and abstract propositions. So, basically instead of the conceptualization of working memory by Alan Bradley, where he thinks about there is something called the visuospatial sketchpad and phonological loop, Anderson's model talks about declarative memory as network of nodes, and these nodes are of two specialized variation. One is spatial image, so space related information, and because this model is a conceptualization of a computer program. So, it has to define spaces, and so that one way of looking into declarative memory is space information or space images. Basically, what in a problem space, how does somebody move? So, you have to know the boundaries of the space and the kind of problems in a space, and that is why the idea of spatial image or space image is there. So, nodes in declarative memory are of two types, either it is space related nodes which tell you the boundaries or the kind of problems or the kind of hindrances that you get while solving a problem, and so that is space relation information, or you have abstract propositions. So, abstract propositions are basically how things are related to another, what is the proposition or what is the kind of rule which relates to information together. So, basically abstract propositions are how two rules are related to each other, because these rules will define how a particular information is accessed. So, rule A and rule B, how they are related to together. For example, let us look at simple rules. So, if A infers B and B infers C, which not necessarily means that C infers A. So, this backward propagation is not there, and so similarly these kind of rules of what relates to what or kind of it is part of a set theory. So, how these rules are there, how these prepositions really work is what is stored in a particular node. Now, also ACT model allows for both activation of any node and for spreading activation of concepts. So, it basically encompasses or it basically includes activation of node and spreading activation to be true. So, if any node is active, the node will pass this activation on to related nodes and non-related nodes together, but related nodes will have high energy and non-related nodes will have lower energy, and that is why it also agrees with the idea of excitation passing over to nodes and the idea of what spreading activation is all about. Further, this concept, the ACTR, the adaptive control of thought, it talks about procedural memory. So, what is procedural memory? It says representation of a series of production rules. So, basically the procedural memory works in this way, that there are certain production rules of how an act should be done. Now, these production rules generally have a goal, it has a starting, a goal and certain kind of conditions, a certain kind of rules to be followed. So, basically it goes in this way, that if you start somewhere, now this start and then there is a goal state. So reaching to the goal state are basically within the goal state and the start state are certain hindrances and certain rules that you have to follow, and if you follow these rules and overcome these hindrances, you will reach the goal stage. Let us try and explain to you what this really means. So, let us say that it is a festival which is going on, and so just near where you live in your hostel rooms or wherever you live, the the place near that everybody is singing in a very good mood, but then you know that there is an exam, right. So, the idea is that tomorrow you have an exam, you are living where you are living, and just beside the window of where you are studying in your home lies, or in your hostel lies, a program where people are shouting and marrying together, or they are making merry. Now, the thing is that the goal is to pass the exam with good marks. The starting point is the position where you are sitting right now, and then there are rules and there are hindrances to it. The hindrances is, if you are there, then basically there will be so much sound that you cannot read, and the rules are that you should not disturb them. So, you have to follow a rule. The rule is that certain rules have to be followed. So, basically if there is a lot of people, so you cannot stop them. By rule they are free to do whatever they are to do, but the rule also says that there are certain possibilities which are here. The production rule says that there are certain possibilities here. For example, one solution to this problem is going to the library, but it also has a rule that the library starts at 9 p.m. So, wait for 9 p.m. then follow the rule of the library, where by rule of the library nobody can shout there. So, even if people want, they cannot shout there, and so one way to reach your goal is to get out or get away from these hindrances is pack your bag after 9 p.m., go to the library, study there till the rule permits, come back and pass the exam nicely. So, this way you have enjoyed till 9 p.m. whatever is happening. After 9 p.m. you move out of there, follow certain rules, get rid of certain obstacles, go to the library which is a solution to it, and then pass the exam. And so, this is basically achieving the goal state, following certain rules and certain hindrances. So, basically these production rules or this procedural memory generally is a if then statement which tells how to perform a particular action. So, if this happens, then this is the kind of thing which is there, that kind of a thing. So, if you want to study for your exam together for tomorrow, then you have to find a place which is silent. If you have to find a place which is silent, then you have to do this, and so there are certain rules, hindrances, goals, and 4-part system which is there. We will talk about this into problem solving when we come to the section of problem solving. Also, production rules specify a goals to achieve, one or more conditions that has to be true for the rule to apply, and one or more actions that results by applying the rule. So, as I explained to you, there is a goal to be achieved, there are certain conditions that should be fulfilled. For example, if you go to the library, that will be silent, and the rule says that it has to be silent, and so you have to go there, and then these are the conditions, preconditions, and one or more action. The action is getting your books, going to the library, studying there, and then coming back. And so, this is how the conceptualization of working memory or the idea of ACTR really talks about in terms of procedural memory. So, basically in terms of ACTR, it is about 3 memory systems which interact with each other, and they lead to the formation or storing of memory data into the human brain. Now, basically then this is how a simple ACTR model will work, and so as you see, this is the declarative memory. So, you have both the motor module and the visual module. So, 2 modules are there, and these collect information from the environment. The motor module contains spatial information, the visual module contains those abstract propositions which are there, and combined to something called the ACTR buffers. The ACTR buffers then also gathers information from procedural memory, because the procedural memory will tell you how to exactly go about the procedure of doing certain things. So, basically how to go about the storing things. So, declarative memory is these 2 parts are the declarative memory, and this information comes to ACTI buffer. The ACTR buffer then talks to procedural memory, which tells you the procedures, which tell you what is to be done, and so the 2 procedures are pattern matching and products execution, and based on that you will come to again to the ACTR. So, this is the input and this is the output, and the output is again fed to the input, and this kind of a chain goes on and on. So, basically any module or any kind of information which comes here is processed through this kind of a thing, and this here it is a simple visual task matching program that I have designed. And so, as you can see, this is how this model really works. The ACPR model really works. Now, in addition to the ACPR model, interesting another model which has been proposed is called the Connectivist model. Now, what is this model? It is a very interesting model, and this model does not conceptualize the way we thought about how things are stored, either as networks or memories, or in terms of concepts, or in terms of knowledge, network of knowledge, or in terms of three kinds of memories. They do not conceptualize this in this way. So, what Connectivist model think about is that what is stored, they say that what is stored in the memory or what is stored as word knowledge is basically a set of changes in the instruction of neurons which send to each other, affecting the pattern of activity that can be constructed from a given input. What does it really mean? It says that what is stored, first of all, it's kind of a copy from the biological model. So, as we saw in one of these classes, I explained to you how memory is stored as interconnections between neurons. And so, what really happens is memory is basically a connection, or it is basically a path from one neuron to the other neuron. And so, what this model says is that what is stored between two neurons is not knowledge or concepts. What is stored in the memory is not knowledge or concepts, it is set of instructions which are stored and which is passed on from one neuron to the another. What are these instructions? These instructions tell a particular set of neurons which are connected to each other to process, how to process data. And so, there are certain modes of processing, and so these instructions basically ask neurons or basically instruct neurons in processing. So, let us look at, I will briefly define this model. It is a very huge and complex model. So, I will try and very briefly define this model for you. So, basically this model learns to develop patterns of activation through many trials with training examples for our example back propagation. So, basically how this model links is, or how this model really works is, there are certain input layer, there are certain input features or input units. Now, a unit has is a pattern, is a unit is thought about as item which receives input from the environment. And so, this unit then passes this information onto a hidden layer or hidden unit or hidden related set of units which are there. For example, verifying Robin is a bird, if it is a very simple statement, Robin is a bird, the Robin, as soon as the Robin unit is activated, it will activate all related units with the bird with it, right. So, things like bird has legs, bird has feathers, bird has beaks, bird has a different color, and so on and so forth. So, all these units will get activated. Now, how does this model really work? So, it has an input unit, and this input unit, when they get an input, some of these hidden, and there is a lot of hidden layer, there is a lot of hidden input which is there. And so, what happens is the strength of activation, or there is a number of inputs which are there. Let us look into this model first of all. So, basically this is the connectivist model of a Robin, and so this is a lot of inputs which is coming from the environment. So, when you see Robin, for example, this is the bird that you are seeing, and so only when Robin is activated, all these things which are coming from the environment is deactivated at that point of time. Only the Robin mode is activated, and this Robin mode now then connects to this hidden layer. So, Robin is, so basically if I am activating the word Robin, Robin is basically a bird, and so basically is, and, has, this is basically the kind of connector to Robin which can get activated. Basically Robin is a bird, Robin can be a bird, Robin has a bird, all kind of connectors are there, and so Robin is activated or can is activated, and so these activations further link to this hidden model or this hidden layer, and this hidden layer then basically gets trained, and then from there the thing is, now Robin is a particular name and can is also a particular name. So, what can Robin do? Robin basically can be both a bird and a person, right. And so, when I see a Robin in the environment, the node which is activated is Robin. If I am saying this is activated and Robin can. So, what can Robin do? If it is a man, if it is a human thing, it can do these many things, but if it is Robin can also be an abstract thing, and so when it is an abstract thing, it can have several other features with it, but when it is a bird, then it can do all these things. These nodes are activated because the bird can grow, the bird can move, the bird cannot swim, and so this is not activated. The bird cannot sing, so it is not activated, maybe it should activate. The bird cannot bark, and so this is not activated. The bird does not have branches, and so it is not activated. So, when a set of input node is activated, these input nodes has a number of connecting nodes with it, right. So, when I look, let us assume an example where I look outside of my window, and when I see several things, I put my attention onto Robin. Now, this Robin has a bird, is a bird, and so there are certain features of Robin which has to be activated. And so, basically this model then says that if Robin is activated, similarly will be activated the word can. Robin can, and Robin can do what? So, you see a Robin or you see a bird which is on the on where your attention is followed, but there are several other things which are there. So, there will be several other nodes which can get activated, but your attention is focused onto only Robin, and so what Robin can do is it can grow, it can move, it can fly, and these three things are the only one which should be activated. Bird could also be activated, but then other things are related to all other things that you have seen in the outside environmental world, and so basically it will not get activated. Now, how does this model really works? So, this model says is that the input layer basically it learns. So, when an input layer is activated, it activates related layers with it, related hidden layers with it, and so it at the beginning of any input cycle, the strength between the input node and the hidden node will be random weights. Let us say if 0 and 1 are the two allowable weights which the input layer and the hidden layer would have at the beginning of any propagation or the beginning of any input signal, the weights between the hidden layer and the input layer would be 0.5. Now, as I said, there are number of factors or there are number of items which compete with each other to start the input, and since Robin has started the input, it will change its weight, right. So, the weight of Robin will become 0.8, from 0.5 it will become 0.8, but all other weights, for example, tree, house, all other things which have been captured at the same moment, but attention has not been put to, the weights of these will change, slowly change to 0.2, 0.3, 0.1, 0.15 or so on and so forth. Only the Robin node is activated, and so the weight of this will increase, it will increase to 0.8, and so the hidden layer will learn this. Now, hidden layer will also get some information both from the perceptual system as well as from the memory system, because Robin is activated. So, the memory system will also feed in some information, and so for example, Robin can, Robin has, Robin kind of a thing. So, it is present tense, and so can would be activated, and so can will have a higher weight, it will, the weights will change to 0.8, and similarly there are certain features of what Robin can do. Now, Robin can fly, Robin can has a beak, it can do this, it can do sing, it can have color, and all those things will be activated, and all other weights will not be activated. Now, basically this model then what it does is, from an input it generates an output, and with that input output system it starts learning, right. And so, what is the meaning of learning? Each time a particular input is selected and output is generated, the connection becomes stronger and stronger. More stronger the connection, the more faster the learning, and so this kind of model basically is a learning model. So, let us look at what this is, and so this, how do we train this model? So, first you show the model that Robin is whatever it is. So, any bird, you show the model any bird, it can do these things, and it can basically result in this kind of a feature, and so it is a training example. From that training example, show it the model a bird. Now, you have started with the idea of bird. So, from Robin change it to parrot, and let us see how the model behaves. Now, parrot is very similar to Robin. So, as soon as it identifies that it is closer to the concept Robin, so it will then adjust the weight between it and the input system and the hidden system as 0.8. It will learn this and similarly output all the features that it is output for the concept bird, and it goes on doing this, and so after training or time after time, it will then develop that this is the feature of what should be of a bird. So, next time you present it a bird that it does not know, which is not a training example, it quickly classifies this as a bird and then outputs a list of features that the bird is going to happen. So, initially connections between nodes are set at, as I said, is set at random weights. Experience leads these connections to be activated more and less strongly. So, the more closely each time when it produces an output, this output is compared to a set of truth features. This output is connected is basically matched to what should be expected as an output, and the closer the match, the better the training. So, if it is not closer, then the model adjusts the weights accordingly and either deletes some of the features or increases some of the features, and this goes on making the weights or goes on making the number of connections. So, training occurs by presenting a specific example to the network which then generates a particular output. So, you start with let us say parrot, and you teach the model that if parrot occurs, if parrot comes in, these are the features you need to output. Next time you start the training with say a sparrow, this is what it is. So, slowly the model or slowly the input layer will understand that okay, once something like this is presented, something like a bird is presented, because it gathers those features, then these are the nodes which have to be activated, and so the nodes which have to be activated then gathers a higher weight and then output which it should present. So, also tell it the output. So, when I show a parrot, show me the output that it can fly, it can wing, it has wings, it can do this, it can do that kind of a thing, and also show me the weights for things it cannot do, and so match it with this idea that parrots can fly. So, this is a verified sentence and this is a true sentence. So, verify with that. Now, next after so many trials, after say 50 or 100 trials, when you show it maybe a different kind of bird, for example, let us say crow, and what does the model do? When you show it a crow, although you do not tell the model this is a crow, the model adjusts the weights accordingly and says that it has a beak, it can fly, and so on and so forth, because these are the proning programs. So, you train it with some examples and then the model learns on its own and starts adjusting the weight. So, it will also give you with the crow, it will also give you outputs like it is black in color, it has 2 eyes, beaks, these are the generic things, but certain other features also it will tell you. Also, training plays in epochs. So, basically these trainings they go about in epochs, and each epoch produces an output activation which is compared to a correct target activation. This is how this model really works, and as I said, these are number of things, these are number of input systems which are activated, only Robin is activated, and so what will happen is only these connections are energized and all connections starts having lower weights. And so, since this feature is related to this feature, so these features add on to this model, and so only A, B, C as you can see is activated here and others are not. And so, when it gets training, in the next training round on the next epoch, it will also learn that it is a bird, it will also learn that it is red or green in color, it is also learn that it has wings and feathers and so on and so forth, and so more number of outputs will be activated. So, it is not only that through these models we can explain semantic memory, there are two more concepts through which we can understand how semantic knowledge or world knowledge is arranged. And so, two of these concepts, one of the famous ways of doing that is what was proposed by Sir Frederick Bartlett. And so, what Bartlett did was he did a very interesting study, and he showed that there is a lot of reconstruction in memory, and this reconstruction is how. So, what he says is that what semantic memory stores is not an exact representation of what happens, but a gist, a kind of a broken down version of the information that is what is stored in our memory. And so, in his experiments he presented something called a war of ghosts, a story to a couple of people, and the story was a complex story. It had many relations and many kind of information into it. They were so interpieced and they were so closer to each other that it was very difficult to break the story apart. And so, this story was presented to a number of people, and when these people who were presented, they were asked to recall the story after a certain period of time back. What really happened is that most of the people remember the gist of the story, the main idea of the story, but they forgot the basic features or the some basic things about the story. For example, names, places, these were mixed up, but the story, the outline of the story was what was there. And so, Frederick Bartlett says that there is a way of storing these kind of information or general world knowledge information, and that is what a schema is. So, then look at what is a schema. So, basically schema represents knowledge in the semantic memory, and that is what Bartlett's proposition is. There is something called a schema. So, what is a schema then? A schema contains general knowledge about the world and information about particular particular event. So, it is not only consisting of general knowledge about words, but it also has information about particular events. So, it has both declarative as well as semantic type of information onto it. Now, schemas are large units of organized information which are used for representing concepts, situations, events, actions in memory. So, basically a schema is kind of a huge, it is a huge box kind of a thing, where a lot of information could be presented into or could be put into, and these information when they are put into, they sort of act together or they sort of work together. For example, Rumelhart and Ortney in 77, they proposed that the fundamental building block of cognition is this schema. So, this schema has information stored into it in kinds of involved knowledge, is kind of a guideline of what should happen. A schema is kind of a guideline of what should be expected. For example, the schema of let us say a village. Now, the schema of a village basically says that these things, for example, bullocks, fields, green fields, water bodies, people, farmers, trees, animals, this is what should you expect in a village. You should not or you cannot expect a car, a modern building or an aeroplane in a village. And so, these are the kind of things which is expected, these are kind of which is not expected. The schema of a village will have this kind of an information. So, basically then schemas are packets of information that contains both a variable and a fixed part. For example, if you look at the schema of a dog, the fixed part of this information is that it has mammals and 4 legs, because the fixed part is shared across all instances of the schema. So, any dog you look into it, it will be a mammal and it will have 4 legs, but then most schemas also have a variable part, and the variable part is where this feature they change across instances or change across variations of the schema. And so, things like breed, things like size, color, temperament, these might change across dogs. So, you might have an Alsatian, you might have a Pomeranian, you might have a Saint Bernard, or you can have any kind of dog which is there. You could have a very light tempered dog, a heavy tempered dog, a highly colored dog, a non colored dog, a Chihuahua kind of a thing which has a very strange kind of a thing, sizes. So, as I said, you can have Great Dane which is very high in size, you can have a Chihuahua which looks like more like a cat, and so on and so forth. So, within dog variations could be there, but then the fixed part is that all dogs have, or all dogs within that particular category or that schema should be same. Also, schema indicate relationship among various parts of information. Now, what do I mean by this? If I am talking about a dog, now the idea is that the dog should have a head, and this head should have 2 eyes only. The tail should not be coming out of the head and or the nose. So, basically there are certain relations which are there among certain parts of the dog, and that is what it is. So, the rear of the dog should have the tail, and the forward of the dog should have eyes, and the color of the dog should be in this variation, the hind leg should be here, the foreleg should be here. This kind of interpretation should be there. So, schema indicates the relationship among the various pieces of information should be there. What is the fixed piece and what is the variable piece, and what is the relation to each other. So, a dog which has legs coming out of the eyes is not actually a dog, an instance of a dog, but a dog which has eyes coming out of the head is basically a kind of a dog. And so, this is the relationship, and so the leg should be below the eyes, and so on and so forth. Also, schemata connects to other schemata in a varieties of ways. So, not just one schema, a number of schemas can be connected to each other. One schema of particular thing can also be connected to another schema of some other things. Now, schema is also used for filling in default values of certain aspects of a situation which help us in making an assumption. So, basically the schema tells us, as I said, the schema tells us what is to be done in a particular situation. So, let us say if you are in an exam hall, the schema says that, or if I am telling you a story of how I met my roommate, class roommate for the first time, I do not need to tell you that what is my age, because most people turn to school around 18-19 years, in a graduation school around 18-19 years. So, this can be auto-filled that this is what your age should be, and so when I am talking, when I am referring to a friend as her, I do not need to tell the gender of this field. So, this can be auto-filled, a schema will provide this kind of a thing. So, when I am talking about a gender, I am talking about that my roommate is a her, then the idea that this is a female is automatically comes in. Also schema exists in all levels of abstraction, thus they can exist for small parts of knowledge also. So, basically what it means is that schemas can be for very small knowledge abstractions, for example, certain letters written in certain kind of ink letters, or it could be the schema could also exist for greater details, for example, like the theory of relativity. So, there are certain schemas within the theory of relativity, for example, the fabric of time, the idea that time dilation happens, the idea that there is something called the space time where space meets time, and then this variations. So, those schemas and also very small schemas of how certain letters can, when combined with each other, give us a perception of a different letter. So, that basically at that level of abstraction also schema should work. So, write A in this way and it becomes a B, or B in this way. You have seen those letters, right, calligraphies of certain kind of letters, and so they also are at a certain level of schema identification. Now, related to the idea of a schema is the idea of a script. Now, script are schemas for routine events, for example, going to a restaurant. Now, what is a script? Think of it in this way. When you go to a restaurant, there is basically a 4-part meal system, right. You start with a soup or some kind of a beverage to start with, then there is the first course, then there is the main course, then there is a sweet, and then you wash your hands, you pay the bill and you move away. And so, basically this is what a script is. A script says how the schema moves in time, how the schema moves across. So, what is the production rule for a schema, or what is the procedure of a schema, or what is the procedure of a routine event is what a script is all about. Now, scripts are used across a variety of situations for filling out unknowns. For example, let us say that I visit a new city, right. So, I visit some city, I am living in some city and I am living in India and I go to the US. Now, when I go there, I need not think what a restaurant should be and how should a restaurant function, because I know from India that this is how a restaurant functions. So, most restaurants should function in the similar way. It is not that in those restaurants something else will happen. The same idea of what I have in India should be a capture of an incident there, and so scripts certainly help us in organizing information or filling up information, or basically how we could use it in different scenarios. Schemas also, scripts also help us in making a number of inferences. Now, what do I mean by that? When I say that you can get a number of inferences. So, a particular script when defined, it shows you that what is the result of this particular thing. So, if a main course is there, what is the result of this main course in a dinner? What is the result of the or what follows, for example. So, if I say that I went to the restaurant and I ate my food and I came back, basically you fill in your head that you might have paid the bill and that then you came back. And so, this filling of information that you arrived at the restaurant with someone, went into the restaurant, sat at a place. So, when I say that I ate food in a restaurant today, basically the all other ideas of you sitting in a restaurant, having ordering the food, eating itself is filled up, and so this information, this inferences can be made from it that you had paid the bill and come, and you have not run away from the restaurant and come out, and so these inferences can be helped. Also, lastly, schemas help us in making an order, and so to test this particular thing, how schema makes us perceive things in an order, this Bauer, Black and Turner, they did a particular study, and so in this study what they did was they presented a story, and in this story the story was made in such a way that there were several concepts in the story and they were in an unordered form. So, some parts of the story, the climax of the story came before, and the beginning of the story was somewhere in the middle, and the middle of the story was somewhere in the back, and that kind of information was presented to people. Now, when a recall was done, most people remembered the story in the right correct procedure, in the right scripted order. So, although the scripts was deviated, people remembered it in the right way from how it began to what was the climax, to what was the middle part, to what was the climax and how it ended, right. So, no matter if we intermix the kind of sequences of a story or sequences of a particular event or routine event, these schemas or these scripts will basically help us reorder these things together. So, basically what we did in today's class is we looked at some other models of semantic memory or world knowledge memory into it, how do they work and what are the pitfalls of some of these model, criticism of this model. We also saw the connectivist model, which is a very interesting model. So, if you are looking up for taking up computational modeling, you can either use ACPR or connectivist model, and these models are interesting models of how they predict, because these models are also used for generating artificial intelligence systems or learning systems. So, basically that is what we discussed there, and then from there we also looked at another way of storing information in terms of scripts and schemas. And so, this brings us to the end of this lecture. Thank you.